Okay, we are looking at something new today. This is a math concept where you're going to be figuring out how to understand one of the pieces of the periodic table. And so the piece that we're talking about is right here. Make this a little bit bigger. There we go. So you guys should have these notes, and again, you can use notebook paper to answer these questions. You can have these notes, just kind of make a copy, store them in a folder where you can be looking at stuff. But we're going to go ahead, and most of this is going to be some practice problems. And so just this first little bit is kind of talking about this topic. And so it's talking about average atomic mass. And so this number right here at the bottom of your periodic table, that's average atomic mass or atomic mass. And so what this is that sulfur has a mass of around 32. So most sulfur you find out there in the world is gonna weigh about 32. So that's 32 atomic mass units or grams. So one thing you might want to write down is that the atomic mass unit is the same unit as it can also be substituted for grams. What I'm going to do here is just go ahead and just write that in here. Just help me out that the atomic mass units could also be represented as grams or grams per mole. Grams per mole. But the key thing I really think for you guys is probably don't worry about that as much. Just worry about the idea that grams are also a unit for that 32.065. So you can think of it as atomic mass units, AMUs, or grams. Okay, so how do we get that number? Well, there's a bunch of different kinds of sulfur out there. Some weigh 32, some weigh 33, some weigh 31, but they're all sulfur. They just weigh a little bit more or a little bit less. So if you cloned yourself and your clone was maybe not eating the best, they were having Doritos and ice cream and a lot of sugary soda, well, they might weigh a little bit more than you. But they would still be you because you're a clone, so you're genetically identical, but they have a little bit more weight, and so they would be an isotope of you. So this number, the 32.06, it takes into consideration all the kinds of sulfur that are out there, and then it multiplies each sulfur mass, the 31s, the 32s, the 33s, by the percent that they are found in nature. So this percent, like how much of them is found in nature, we're gonna call that abundance. And so right here it says relative abundance or percentage. So if you look at this sulfur, if you round it, say we'd probably round it to a whole number, we'd round it to 32. That means most of the sulfur out there weighs 32. Some of it weighs a little bit more, some of it weighs a little bit less, but a high percentage of it would weigh 32. All fine and nifty, but we need to understand how to work a problem. Don't want to do that. We want to understand how to work a problem. And so I'm going to slide down here to the problem. So if you look when you work these, I will want you to make sure that you are showing your work and that you are circling your final answer. If we're not going to show work, we're really not going to be learning anything, because a lot of chemistry is based upon the steps, the bookkeeping, the process. And so I need to see that you know what's going on. Okay, so these problems are all pretty similar. They're going to give you some percentages. So they gave us some percentages. So they gave us this 92%, 4.7%, and 3%. So now if you add those up, the real specific ones, they should add up to 100. And then they gave us a mass value that would go with each of those. So this one is a atomic mass units or grams. It goes with this one, right? So they go together. And then like here, we've got the 4.7%. So it's going to go with that one, the 29 AMUs basically. And then the last one here, we've got the 3% and then the 29.74. So this is pretty straightforward. The way you work a problem like this is you're going to multiply the percentage times the mass and then add all those values up, and that's going to give you the average atomic mass. Oops. The average atomic mass, or that 32 number right there. Okay. So that's what you're going to end up creating. So let's do the math. Do need a calculator here. You cannot just watch me do math and learn it. You need to do it. So let's go ahead and get started. So first thing you do is you take the mass and multiply it by the percent, or the percent times the mass. Doesn't matter. I'm going to do the mass first. So I'm going to do the 27.977. So that's grams or atomic mass units. And I'm going to multiply that by the percent. Okay, but the percent in your calculator is not 92.21. In your calculator, percents are going to be a decimal. So if you don't know this, to convert this into something I can put in my calculator, it would be 92.21 divided by 100. That's how I'm going to plug in my calculator, or move the decimal 2 spots to the right, 0.9221. So that's what you're going to put in your calculator, right? You're not going to put 92.21 in your calculator. That's not going to make a lot of sense, right? Because that's not a percentage. So that's the percentage in your calculator. All right. So need to know that so that you're able to figure these things out. Just move it 2 spots to the left and you'll be fine. So let's go down here and let's start this again. I kind of don't think I have enough room there, so I'm going to start it again. And that's pretty quick once you know those couple tricks there. So we'll go back to our blue pen, and off we go. Okay, so what I'm going to do is I'm going to take 27.977, and we're going to multiply that. I'm going to switch that real quick. We're going to multiply that by 0.9221. So that your calculator understands that's a percentage. So this is 92% weighs 27.997. So we're going to add that to the next one, which is going to be 28.976. So that's right here. And I'm going to multiply that by its percentage, which is, 4.7%. So if you move the decimal 2 spots to the left, or you divide by 100, right, then it's going to be 0.047. The zeros aren't going to matter at the end, but I can plug them in for you. And then we're going to add to the last part, which is going to be here, 29.974, kind of run out of space here, times, and I'm going to try and sneak this right here, times 0.0309. All right, look, I fit it in there. So that's 0.0309. All right, so maybe I should try that again. Let's try it again. 0.0309. Okay, look, that looks pretty good. All right, so then you're going to do the math. So remember that we want to do this piece and then add it to that piece, and then add it to that piece. You want to make sure that multiplication happens before you dive in and have an answer. So let's plug this in our calculator. I'm going to do it right now. So 27.977, I'm going to multiply that by, in my calculator, by 0.9221. That's 92%. I hit enter. Okay, so I hit enter after that step. Okay, and then I'm going to add that answer to, now I'm going to use parentheses, to 28.976 times 0.047. Excuse me. And so hit enter again, close your parentheses, then hit enter. Then I'm going to add that answer to, in parentheses, 29.974 times 0.0309, close parentheses, hit enter, and then you're going to get a number. So your number should be between, on all of these, it needs to be between your high value and your low value, right? So here's our highest value, 29. Here's our lowest value, 27. It has to weigh between the highest and the lowest, because if it doesn't, we obviously did something incorrect on our calculation. So I got 28.08 5603. And I know we haven't talked about rounding yet. So on these, just go ahead and round to like 2 decimal places. That will be fine. We haven't gone over sig figs with you guys, so not a big deal. So just give me an answer of 28.08, and 2 decimal places is fine on these. And that's atomic mass units or grams. All right, so I'm going to pause it here, guys, and I want you to do the second example. So I'm going to slide it up, or sorry, slide it over. I want you to work on this example right here. So you guys work on that and try that on your own, and then on the next video, I will work that one with you.